Hi, my name is Alex Williams, founder of the New Stack, and you are listening to the New Stack Analysts podcast. Each week, we discuss our latest data research and a topic related to app development and back-end services. My co-host for the show is Donnie Berkholz of 451 Research. SignalFx is the sponsor for this week's show. SignalFx is a SaaS provider for monitoring modern applications. You can find them at signalfx.com. Now let's get to the show. Okay, hi, Alex Williams here of the New Stack for the next episode of the New Stack Analysts podcast. Here today with my co-host Donnie Berkholz. Donnie, good to see you. Donnie is here.
Good to see you as well.
A little echo, but we'll take care of that. And we also have today James Turnbull, Vice President of Engineering at Kickstarter. James, great to have you here today.
Thanks so much for having me.
Great. And we have the two folks from SignalFx, Karthik Rau, CEO and founder, and Phillip Liu, CTO and founder. Great to have you guys.
Hi, Alex. Great to be on.
Hi, Alex. Great to be on.
Yeah, great to have you. So the topic today really is on this whole conversation of modern monitoring. And I'd like to first, ask the SignalFx team here, Karthik and Phillip, if you guys could tell us a little bit about SignalFx and what do you do. And we really appreciate your support and sponsorship, and just to give you an opportunity to tell us a little bit about SignalFx.
Sure, Alex. SignalFx is a SaaS-based monitoring service, and it was really designed from the ground up to provide better monitoring and visibility for modern distributed applications. Our belief is that more and more we're seeing new applications essentially being designed as distributed applications. You're seeing more and more microservices architectures, and it's quite common to find applications that have dozens, hundreds, potentially even thousands of components. And in such environments, you really have to rethink how you do monitoring. If you're simply doing health checks on individual nodes, you can just create a lot of noise. And what we're finding is more and more progressive organizations are looking at more of an analytics-based approach to monitoring, where you collect data up and down the stack and across different services, centralize it, and run analytics to try to identify patterns. And that becomes a lot more meaningful when you're monitoring modern applications. So SignalFx is the SaaS-based monitoring service that really makes it very easy to analyze all of your metric data across all of your different services and focus your time really on drawing insights from your data rather than having to worry about maintaining and building all of the plumbing. So maybe I'll ask this question first to James. Why is there this need for modern monitoring at all?
I think the SignalFx folks have sort of highlighted the key sort of thing, which is the change in architecture. But I think more importantly, traditional monitoring was already broken. So I think the change in architecture is somewhat of a side effect. Traditional monitoring were things like Nagios, where you actually cared about things like fault detection. So you would say, wire up all of your services and all of your hosts, and you would ping them and ask them about themselves. And if a Nginx or Apache stopped working, it would send you an alert. So what people ended up with was mailboxes or pager queues full of alerts that basically said something has stopped. And that's the most insight you would ever get out of that sort of monitoring. And that doesn't scale. It's not very useful. And if you get woken up at 4 o'clock in the morning, the message saying Apache has stopped, how much use is that to you? And as a result, operations people started ignoring those alerts. And I think we've seen that fundamental process needs to be updated.
So Donnie, what's your thoughts? Why is there this need for modern monitoring?
I pretty much agree with what James has been saying in terms of people I think want to work with monitoring in terms of logical applications, and whether that's microservices or not. A lot of companies are sort of scaling out their IT footprint without scaling out the team behind the IT footprint. You know, if you look at something similar, you talk to sort of cloud-driven companies today, and they're trying to maintain something like 10,000 systems with one SRE versus, you know, the traditional approach where it's like, if you've got 100 systems sort of manually maintained with command prompt login and all that good stuff, you're doing pretty well with sort of an old school system. And it's the same kind of thing where, like, how do you scale monitoring to that many systems? Well, you've got to have a smarter approach because, you know, even in the world of 100 systems, if you've got, you know, alerts coming off all the time, shooting off saying, hey, you're at, you know, 10 gigs free on your disk or whatever, you better maybe have something actionable about that, but probably not. You know, it just doesn't scale, right? You've already got clogging inboxes with 100 systems, let alone 10,000. So you've got to come up with something a little bit smarter that can think about things, you know, more logically and more functionally.
So
and a lot of those alerts are, sorry,
go ahead.
I was saying a lot of those alerts are kind of useless too. So, for example, that disk space alert that Donnie's just highlighted, it's like you have 10 gigs left on a you know, this size disk drive. Doesn't actually tell you anything particularly useful. It's like, how fast is it growing? How much is it changing? What you really need is trended data that says that, oh, you have 10 gigs free, but it's not going to actually run out for another 2 months at the scale it's growing. So you shouldn't care about that alert. That should be a low priority alert. Whereas you have 100 meg left on, you know, an important partition and it's growing at a, you know, 10 megs a second, then you've got a really big problem and you need to address that.
So I would like to ask this question of, you know, of Karthik and Phillip. Can you tell us, you know, what does it mean to build a scalable monitoring service? In particular, you know, how did you guys do it? Because I know you guys you had to pay a lot of attention to that yourselves in building your own service.
Yeah, so this is Phillip speaking. One of the problem with these mono architectures that there are so many instances. So and talk a little bit about scale and why that's necessary. And you know, with the advent of infrastructure as a service, or success of the infrastructure as a service, many people actually are spinning up not tens of instances anymore. They're easily into hundreds of instances. And their services are, in terms of number of instances out there, are just much, much bigger than it was before. And so in order to look at data across large number of instances, you have to be able to build a monitoring service that's able to consume large amount of data. And one of the key things that you have to do is not only do you store the information, typically a lot of systems do that today, it'll give you a nice post-mortem analysis tool, but in order to use it for monitoring, you have to be able to respond to the problems as they occur. So as you detect the fact that your disk rate is increasing at a high rate, you want to be able to act on that in time. So you can't wait an hour later until you run out of disk space. You want to be able to act when you actually detect that. So part of what we do is we built a large, massive streaming analytics engine that's able to ingest large volumes of data and be able to calculate things like the rate of change on your disk space across your entire service of hundreds and maybe thousands of nodes within milliseconds and seconds. So then you could then detect that fast enough and act on it.
So at Kickstarter, James, how have you guys built your a scalable monitoring service? What are some of the key learning things that you think back on now in developing that, since you've been there at least?
So we very much care about metrics. We don't actually care very much about individual faults. So, for example, you know, we obviously operate a large web platform. You know, losing one web server is not a big deal. Losing 10 is a big deal. Losing one web server is probably not hugely reflected in our metrics, but losing 10 actually shows a distinct change in the, you know, the traffic pattern or the number of errors or something like that. So we rely heavily on our application and our host generating metrics. We send those metrics through to Graphite, which is a graphing tool, and we have a series of 4 or 5 graphs that present the sort of state of the union for the Kickstarter platform. and we monitor those to determine when something goes wrong. So, for example, if we deploy a new bit of code, then somebody watches those graphs to say, okay, the code's gone through, or wow, we've got an escalated level of, say, 5xx errors on our web front ends. There's some problem we need to look at. Our actual sort of fault detection stuff is fairly limited. We have a tool, Nagios, running in the background, but it's largely, it doesn't really generate a huge number of alerts, and it's not something that's sort of integral to our process.
How have you had to optimize
James,
it?
one thing I'm curious about, James, is are you actually using the graphing in Graphite, or are you using some tool that's a little bit less pixelated?
We actually have a built-a tool on top of Graphite's web console. So we don't actually use the Graphite web console itself. We built a tool that uses their API to generate graphs for us, because we found I think everyone would admit the Graphite console is not the most intuitive tool in history.
Indeed. Yeah, I'm not surprised somehow. I mean, it's, one thing that I've seen over the past few years is there's been this sort of resurgence of design in monitoring, right? When you look at tools like Graphene is a good example, right? Another sort of dashboard on top of Graphite, but it's built with D3 and Backbone instead of looking like RD tool graphs from like 2002.
Yeah, I think obviously the SignalFx guys here actually sell a product that does some of this, but that visualization, that ability to build a graph that an SRE can look at and at a glance know there's something wrong is a really hard problem. Like, designers have been doing this sort of stuff for a long time, and coming up with a picture that says, an SRE is really busy, can quickly flick their eyes at a console and go, wow, okay, that doesn't look right, and drill into it. That's a hard thing to build.
What have been the considerations in building that, Karthik and Phillip? What are some of those? What have you learned from SREs to help you build that tool?
Yeah, so I think some of the key thing is that we found quite often that when SRE actually detect a problem, they want to be able to dig into the sea of data that's available to them, or sea of metrics that's been submitted within the environment. And one of the great way to do that is interactively dig into to the metadata that's been deliver into the stream as part of the metrics. So not just a flat stream of what you're measuring, but also some identifying data as to what environment the data came from. And then be able to quickly dig into that data set. For example, look for things like, I think one of my services is running hot in a particular region or in a particular data center. So how do I actually quickly dig into that? And then once I dig into that and I find a combination of things that tells me what is wrong, for example, service A, disk partition actually occasionally will run hot. And then now I know this is the problem. I want to be able to then save that in a representative chart that I can come back to anytime where I suspect something like this is happening. So like that exploratory process, we spend quite a bit of time on getting right in our user interface, and obviously we'll continue to make innovations on that front. And I think that's one of the key things that SREs actually spend a lot of time around.
So there's kind of this whole question about the data measurement aspects of this new world of monitoring. And I'm curious on this aspect of it, and why it's so important to instrument metrics versus, for instance, dumping everything into logs or relying on checks. Phillip or Karthik, can you address that?
Yeah, I think our philosophy on that, and what we've seen a lot of progressive organizations do, is instrument as many metrics as might be relevant down the road. Because when you have a scenario where you have a performance issue or you have error conditions, having those metrics readily accessible, especially if you still have if they have those metrics streaming in, you can get a much better sense in a very interactive way of what's happening in your environment. The other thing that's also very important is when you look at a lot of these modern applications, they're not monolithic applications. You've got different services and you've got different owners of different services. And if all of your data is in logs, it becomes very difficult to communicate across different teams, to be able to share context and understand if you have a degradation in service B and that has a downstream implication on service C. You may have different teams of developers that all need to share information and figure out how to solve an issue. And if you have metrics instrumented and you have it in a service like SignalFx and you can share dashboards and you can interact with that data, it can drive a couple of things. One, much more proactive monitoring where you can detect issues as they slowly start to arise between different components. And when you have a problem, you can actually very quickly start to debug it across different teams.
Yeah, so I think I'd like to add to an interesting use case that we actually here encounter ourselves. So one of the things that many people use logs for today is to look for exceptions as they occur, and to be able to count the exceptions and historically, hey, how many times have this occurred in the past? And then that would be an indicator of something that has happened in the past. So what we've done here is that we actually ran into similar situations where we, I want to talk about a specific use case where we have a RC deployment with our service. And typically what we do is that a service owner will deploy the service. It will check all the metrics to make sure everything's okay. And then, every once in a while, we'll tell the logs a little bit and say, hey, are there any exceptions that has occurred? Now, that works great if the RCs, if the new code is introduced, affect only the service itself. But typically, in a microservices environment, you deploy code in one service. You have downstream effects that's not immediately visible to you, but it may be visible to other services. So one of the things we done was we actually tail logs and then emit a metric into SignalFx that basically count not only the air conditions with the service that you're pushing, but also the air conditions across all the dependent services. So when you push an RC, then if you would observe the rate of exceptions as it occurs within the rest of your service, dependent services, you can know that not only are you introducing something that's, you sort of find out if you're introducing an error that's being observed downstream. So I think that itself is actually quite useful. And then instead of depending on this log systems, which takes normally a long time to be able to index, or a long time relative to metrics, be able to index and then report on, post facto, you're able to sort of catch things right away as you're doing these RC pushes, or if you're doing these incremented rolling pushes on your environment.
Donnie, do you have any thoughts that I know you're going to have to get going pretty soon? I'm curious in your thoughts on these are very modern kind of ways of addressing monitoring. And you deal with, you talk to lots of people in this world. Are you starting to see this trend?
Yeah, absolutely. In fact, it's kind of ironic that we're having this conversation right now because I just finished writing up a report for, I guess, my new paywall clients, unfortunately, on this whole trend right here. So, the timing is great. But yeah, it's absolutely a trend that's been happening, for at least the past 2 to 3 years now. And I think it's just going to continue to increase. And, the biggest question, well, I guess there's a couple of big questions right now. One is, one that often comes up from people like John Allspaw, which is the single pane of glass. Can that ever be the right answer? And then two is, with all the advent of things like machine learning and anomaly detection, can they ever, solve every problem, or is there always going to be a role for humans to sit there staring at walls of graphs? And I think those two, sort of remain to be resolved. They're both very hard.
Yeah, I was wondering that myself when we were talking about, when James, you're talking about the graphs, those kind of core graphics you guys use, to see how the overall architecture is behaving. And you said you start to look for different things. And are there people watching those all the time, or do you guys have an alert system designed for those SREs so they don't, so it's not just that constant monitoring?
I think you have to divide this into two problems, and John Allspaw has a recent post on this on his blog that makes this a bit clearer. But I'm not looking for a monitoring tool to provide me with a single pane of glass. I'm looking for a monitoring tool that will help me identify problem areas that will, I can then drill down onto and work out what's going on and troubleshoot. Like I'm not expecting a huge amount of troubleshooting or diagnostics to emerge out of my monitoring system, because I think that's a human problem, and humans are much better at solving those problems. but they need to be pointed at the right place. So we rely very heavily on metrics to tell us that there's a problem, and then we underneath the surface of those metrics, we collect everything we possibly can, and someone is then able to take that data and drill into it and say, we found a log entry or a series of log entry that indicate a problem, or we have some performance data, or a particular host is playing up, or a particular application is misbehaving. I'm looking for a tool that's sort of a partner rather than one that's sort of going to provide sort of a magic, single pane solution.
So, Karthik and Phillip, what does that partnership look like in your view?
Yeah, so I absolutely second that. I think that, and we think that out of the box, so we will provide statistical tools to help the SRE, the developer, figure out and then sort of dig into the sea of data to try to find a signal that give them indication as to where to start looking. And over time, we think that this set of tools will get, the toolbox will get broader and then maybe smarter. So we'll actually let our users point maybe ML algorithms against some set of data to see whether that makes sense or not. But I think it'll be a while before we actually think that, or it'll be a while before a machine will automatically find the problem for you, and then for you to be able to trust that the result and be able to act on it. So
yeah, I'll just add. This is Karthik. A couple of things. So we absolutely agree with James on this, and that we believe that machine learning can help elevate patterns that look unusual, but ultimately it's a human's role, and a human is much better suited to determining or identifying what might have been some of the causes of those anomalous patterns. One of the other things also to consider, we as a monitoring vendor recognize that in today's world there is a massive fragmentation of applications that did not exist 20 years ago when people were mostly dealing with packaged software. When you look at the number of people building software applications and how frequently they're changing in today's environments, you've got companies like Kickstarter. You're probably making code pushes at least on a weekly basis, and they might be small changes, but there are always changes happening in these applications. And so, as a third-party monitoring vendor, or any third party, can't really automatically assume that they know the application better than the people that are building them. And so, what we can really do is provide a very rich set of tools to help the owners of the applications, the humans who are making the changes on a daily or weekly basis, identify issues very quickly and provide a tool for them to troubleshoot and root cause very quickly.
Yeah, I agree. I very strongly agree with that. We deploy 5 to 10 times a day. We don't. Our expectation is that we as the subject matter experts of our own code base, your machine learning tool is probably not going to be able to catch up with us. And we're really looking for guidance rather than sort of, some magic anomaly detection.
Well, who are the kind of the people that are starting to do these things? What are their roles? What is their specializations? And are organizations needing more of these people, or do they even need to start looking for these people who can specialize in understanding this new modern monitoring environment?
Well, we don't use any specialists as such. Any engineer in our engineering department can deploy. We don't. You can call it DevOps, whatever you like. But my view is that if a dedicated team that is sort of focused on deployment and that's probably not something that's ideal. I think everybody in the organization needs to understand how that deployment process works and what the impacts are, and be responsible for the code they ship. We do have a couple of people in the organization who are more specialized sort of SRE sort of people, but they write code as much as anyone else does. It just happens to be focused on a different set of problems. So I think that dedicated SRE function is something that ultimately needs to change.
Do you guys agree with that, Karthik and Phillip?
Yeah, we see more and more. It's just a part of the development function or the product function, right? You have component service owners who bear some operational responsibility for the changes that they're introducing into the environment. And so they need tools to be able to get the visibility that they need so that they can be, accountable and responsible for the changes that they're introducing into the environment. Now, we have seen certain amounts of specialization, especially as an organization gets larger, there may be more dedicated infrastructure and engineering teams or operations teams or SRE teams that play a role in providing better leverage and tools. But by and large, we see more and more ownership, being driven into the product teams. You make a change and you're responsible and accountable for the impact of those changes.
I'd like to move into some a little bit of the conversation we're having, overall we see on the news stack quite a bit. Our conversations about microservices and the microservices architectures. And Karthik and I had a conversation about this a week or two ago, and about how, for instance, these new container ecosystems are leading to kind of a deeper realization that data is much more relevant than before. So I guess, James, I'm curious from your perspective, why does using a microservices architecture lead to needing analytics as a core function of a monitoring platform?
I think the big difference is there's a couple of things. One is dynamic. It's a much more dynamic solution. Microservices tend to be small clusters of hosts that change frequently. I mean, if you look at the Docker container world, for example, your large Docker containers are largely expected to be ephemeral, so they're only expected to exist for a short period of time. As a result, it's not like the old days of a monolithic server and a monolithic application running on top of that server where it doesn't change. Like you have this, application1.example.com is your host name forever. It's got the same IP address. It spits out the same JVM metrics all the time. You can no longer build monitoring systems around these monolithic artifacts. Your container you may spin up 1,000 containers in an hour, all of whose names and IP addresses and you don't care about. All you care about is the service that is running through that container or through that application or through that microservice. And those things are, what do those services have? They have metrics. They have transaction throughputs or response times or latencies, and those are the numbers you now care about.
How are you seeing this come to realization, Karthik and Phillip?
Well, I think just the move towards metrics-based monitoring is, I think people are realizing that what matters more, your monitoring logic has to move from the individual, because what you care about are trends across the service, not what's happening on an individual node. You might still care about what's happening on an individual component, but not with the same level of urgency as what is happening across the entire service. And so we see more and more momentum towards instrumenting metrics and building analytics around metrics. And I think there's a large correlation between the rise of microservices architectures and this need for a more modern monitoring solution.
So with these new microservices architectures, what are you seeing? I mean, I'm curious from Karthik and Phillip, your perspective. What are some of the questions that are coming up about microservices architectures, and what are the contextual issues that they're bringing up with these questions that they have?
Well, I think there are with microservices. I think one of the things that's different is, as James had mentioned, you have more elastic environments where you can potentially see an individual service scale up or scale down very frequently. You oftentimes have a lot more dependencies between different, you've got, different services that are sometimes updated on different cadences and have upstream and downstream dependencies. And so there are a lot of questions that people ask and they're unique to their own applications. If you have a performance issue arising, you need to understand where did that originate, and was it an upstream or a downstream service, or kind of getting a better picture of that becomes very important. Error conditions, may have all sorts of other dependencies across dependent services, and so there's just a lot more collaboration required. And the questions are unique to every organization, but we've certainly seen a need to build tools to provide better communication in these environments.
Yeah, I'd like to sort of add to that a little. So, one of the things that happen in a microservices environment is that disparate team owns part of an application. So let's say that one application is comprised of many different services, but disparate teams own different parts of the app. And then, like one of the examples I gave earlier, that if service A makes a change in a deployment, is actually sometimes it may have side effects that's not expected. And in the past, if you were to push one big application, the application just won't work, right? So then at once that, hey, this app server, I'm looking at the logs and it doesn't work, so I'm going to pull it back and then redeploy. As simple as that. Now, in this microservices environment, you're pushing one component, and then downstream, that may be affecting other components in the form of another service. And unless you have a holistic view or a view or system that allows you to look at multiple components at once, you won't have insight into what's happening or what effect you're causing into this microservice ecosystem.
So what are some of the new complexities that containers are bringing, with kind of more traditional monitoring practices? What are some of the unknowns that you guys you're still thinking about how you manage like these tens of thousands of containers that will definitely be part of emerging infrastructures as companies start to adopt these technologies?
Yeah, I will say that elasticity is a big problem. As James alluded to earlier, that we also see some of our customers bring up, they will spin up applications, much like maybe not as fine-grained as creating objects, but similar. The developers sort of think of it in similar ways. So therefore, that there are a lot more elasticity that's happening in the environment. I spin up 100 instances to deal with a burst, and then I spin it right back down. That's actually part of the orchestration infrastructure and part of the design of the application. And then so that itself is actually something pretty complicated to deal with, because even though you could look at things in aggregate in terms of size, in terms of how much load you're supporting at any point in time, the number of containers you have at that point in time, and sometimes that it becomes harder to know, well, if you spin up this many containers, you run into some set of scale problems, but you don't have with a lower number of containers. And then that's actually something that's interesting from a monitoring perspective.
So James, what are some of the complexities that you're starting to see emerge that are raising some questions, and challenges that containers bring to monitoring?
I think the audit scaling one's really interesting, that sort of elasticity. I think it's very easy to make statements like you spin up 100 new containers. It's even relatively easy with things like AWS to actually do that automatically. It's when do you spin it down again that is still an unanswered question. A lot of it is infrastructure. Scaling up is easy, scaling down is hard. I think too, there's also the very fact that all of these systems exist, tens of thousands of nodes at a time, massively complex interactions between services. We have a really big, I would describe as service discovery problem, which is that, these services are really dynamic. They change their names, locations, IP addresses, port numbers, on a second by second basis. So you need a real-time, distributed, highly available sort of service that can able to tell you about those things. So if I spin up 100 new web servers, I need to be able to tell my load balancer about these 100 new web servers. And by the way, 20 of them just disappeared because a host went down. Now I need to remove those in sort of split-second time while providing minimum disruption to the that's a really hard problem to solve still, and hard problem to monitor for.
So that gets into the question, I think, about that need for real time. Does monitoring really need to be real time now? Or does it just need to be really fast?
I think some monitoring needs to be real time. It depends on the definition of real time, right? So, monitoring that is 5 minutes old is probably poor. Monitoring that is 5 seconds old, depending on the scale of your platform, may be okay. monitoring that is 5 milliseconds, you'd probably want to be doing something like high frequency trading, or your monitoring may detect something, but if there's a human in the loop, it's going to take that human longer than 5 milliseconds to respond to it. So I think you also need to divide out between the granularity and the resolution of your monitoring and your metrics. What's useful later on to be able to drill down and say, okay, this error is occurring at microsecond intervals, and I wouldn't have picked it up otherwise if I was measuring things at a much, higher resolution rather. And then also the sort of real-time view of the world. So view and versus, collection.
So, I'd like to just wrap up here with Karthik and Phillip. Do you guys have any thoughts on this? On this new real-time world, and I guess the question then is, like, with this real-time world, what does this allow? With these metrics that you're talking about and these analytics that are available now with these new streaming architectures that you could not do before.
Well, I think Phil had touched on it a little bit earlier, in that you want to look at your metrics infrastructure not just as a historical root cause analysis tool, but you also want to be able to use it as a proactive monitoring tool. And if you can build aggregations on all of these metric streams within seconds of receiving the data, then you can get a much better view about what's happening across your entire service, instantaneously. And that's great for monitoring. It's great to proactively identify issues. And that's really what these streaming architectures like SignalFx really enable. Within seconds, you can understand what is the 95th percentile of latency for a key API call across the entire service. And if something starts to trend upwards, you'll know within seconds, and you can proactively address it. Now, in some cases, maybe it's unexpected and you get an alert and you can proactively try to address it before your customers start to notice effects. Or in other cases, maybe you're doing a canary deployment and you're rolling out a new feature to a subset of systems, and you're actively watching the dashboards and seeing, as you've done a code push, you see something that looks unusual, so you can roll it back. So there are lots of different use cases, but the fact that you can get instantaneous visibility into larger patterns is really what's important here.
Great. Well, thank you guys very much for participating today. I know you're going to have to get going, and I know everyone's busy, but I just would love it that, maybe James, we could conclude. Could you tell us a little bit about what you're working on these days in terms of the monitoring space? I know you've been working on, a project, and would love it if you can share a little bit about it.
Sure. So I'm working on a book called The Art of Monitoring, which is artofmonitoring.com. It's really focused around this sort of modern monitoring. It's very metric-centric, it's very event-centric, and it's it's taking people through building a metric-centric, event-centric platform. This is something obviously behind the firewall and on-premise sort of solution, and really looking at different ways of re-architecting monitoring. So I'm looking at more push-centric monitoring, so where applications report their metrics to a service rather than pull-centric, which is where things like Nagios, where things are polled and asked about their state. And I think that's a model that sort of really fits more closely with that sort of distributed application world that's coming up there. I hope to have that released in the next few months.
Great. Well, look forward to that. Well, thank you guys all for participating today in this podcast about modern monitoring. I'd like to thank Karthik Rau, CEO and founder of SignalFx, and Phillip Liu, CTO and founder of SignalFx, for joining us, as well as James Turnbull, Vice President of Engineering at Kickstarter, and Donnie Berkholz, who was able to join us for the first 30 minutes of the call. In any case, thank you very much, all of you, for participating in this podcast, and look forward to keeping in touch.
Thanks, Alex.
Thank you.
Thanks, Alex.
That's it for this week's show. Thank you very much for joining us. I'd like to thank our sponsor, SignalFx. SignalFx is a SaaS provider for monitoring modern applications. You can find them at signalfx.com. Audio editing and sound design for the new Stack Analysts podcast is provided by Broken Hours. You can find them at brokenhours.com. Thanks again. Hope to see you again for the new Stack Analyst podcast. Bye-bye.